You know, the very strange weather that we're having around the world in New York, these incredible cold spells that we have had. Who had ever heard of the vortex in New York, right, before that weird weather? The incredible heat that Australia has suffered, the floods in the UK, and you name it, it goes on and on and on and on. There's no country that has been exempted. These very strange extreme weather events are going to continue, both in their frequency and in their severity. It's not that climate change is going to be here in the future. We are experiencing climate change.
This Arctic blast could see America reach its coldest temperatures in decades. Millions of people across a huge swathe of the country are being advised to hunker down while the so-called polar vortex does its worst. Minnesota could be hardest hit, with wind chills set to make it feel like an astonishing -50 Celsius. The polar plunge has struck unusually far south. In Oklahoma, the rotating pool of freezing air is producing rarely seen temperatures.
The inside of the New York to Washington, D.C. train iced up.
Try opening the window in Chicago and you'll get this. 35 below zero right in your living room. It's so cold, Lake Michigan looks more like a hot tub. The water outside Chicago warmer than the frigid air, and ice already forming along the banks.
Images of water turning to ice before it reaches the bottom. Parts of Niagara Falls have become frozen.
South as Texas and here in Elk City, Oklahoma, heavy snow is falling. This is unusual even for winter.
This weather combination that we're seeing right now with all of the snow and the cold is unlike anything that we've seen in decades. And I can't emphasize that enough. The cold really scares me. And as such, that we're going to have temperatures that are potentially deadly or certainly life-altering temperatures.
Hundreds of flights continue to be cancelled, leaving passengers stranded. While on the coast, not far away, seawater, which flooded some communities during the storms, has now frozen over, marooning people there too.
Severe, pervasive and irreversible, words used in a new UN report about the likely impact of global warming. Amid extreme weather worldwide, experts say the health, economic prospects and food and water sources of billions of people are at stake. It's everything from droughts to rising sea levels.
We're not in an era where climate change is some kind of a future hypothetical. We live in a world where impacts of climate change are widespread and consequential. We see impacts from the equators to the poles and from the coast to the mountains. There's no question that we live in a world that's already altered by climate change.
Powerful waves have continued to pound Europe's Atlantic coastline. 2 people are now feared dead in the French holiday resort of Biarritz after they were swept out to sea. The town's famous promenade was battered during the night, leaving many businesses to pick up the pieces on Tuesday morning. The surge wasn't isolated to France. A large stretch of Europe's Atlantic coastline was hit by high tides, including Portugal and the Spanish region of Galicia. At least 1 person is now known to have died in Spain, with 2 others still unaccounted for. In Portugal, this amateur footage showed one man's desperate attempt to save his car, just managing to escape in the nick of time. Elsewhere, near the capital Lisbon, the swell was so bad, huge pools of foam like this started washing up along the shore.
Time to go! An earthquake of around 7 magnitude has struck China's far western region of Xinjiang.
The earthquake that shook central New Zealand, including the capital, Wellington. The minute-long 6.3 magnitude rolling.
Thousands of residents woke with a bang this morning after a series of earthquakes rocked the state. Many have told of their fear and confusion as the shockwaves rumbled through the suburbs.
Tremors and shakes were felt right across Metro Adelaide.
We have very few this close to Adelaide that are of this magnitude, so it is more unusual.
South Carolina and Georgia got a bit of a shake last night. An earthquake with a preliminary magnitude of 4.1 shook homes and rattled residents' nerves.
It's the second largest earthquake to ever hit the state.
A 6.9 earthquake hitting off the coast of Eureka.
Already 4 aftershocks.
Chile has ordered an evacuation of parts of its northern coast following an earthquake with a magnitude of 7.0 jolted an area 35 kilometers north.
Whoa!
Whoa.
Big earthquake.
Big earthquake right now.
Big earthquake. That's
a really strong shaker right now.
Very big.
I still feel it. Are you still feeling it?
Yeah.
Steady
it's
shaking
still
there.
shaking.
My hands are shaking.
A 4.4 magnitude earthquake has shaken Los Angeles. This is the second quake to hit the state in a week. This is the strongest quake to hit the city since the last aftershocks of the 1994 Northbridge quake. The United States Geological Survey said there could be a 5% chance of another strong quake within the next 3 days. Local residents in Nova Scotia and New Brunswick woke up to a bit of a surprise when a giant fireball illuminated Canada's skies early on Tuesday morning. CCTV captured the incredible moment when a bright burst of light lit up the sky. The fireball, which is thought to be a meteorite, could also be seen from Nova Scotia, where eyewitnesses said they saw bright lights in the sky and heard a loud noise like thunder at around 5 a.m. local time.
Alpha 6412, where do you want it?
Not real often.
There's like a mudslide and everything's gone. The houses are gone.
Are there any injuries?
Yes, there's people yelling for help.
A desperate call to the emergency services as a deadly tide of mud and rock crushed everything in its path. Houses were swept off their foundations, trees keeled over, and people were sucked into the sea of mud like quicksand.
24 people are confirmed dead and 170 others are still missing. It's believed a small earthquake may have triggered the tragedy.
It's like a war zone up there. People finding children, people finding babies.
And while the task of finding bodies is already so grim, some have had the even more unimaginable trauma of finding only partial remains.
The slide hit with such force that oftentimes the rescuers are not recovering full intact victims.
Massive turnout by the emergency services personnel going through their districts, checking. A lot of rolling going on down here. My family lives down here in Orange County. They said it was quite violent. It went on for quite a while, so a pretty good shaker coming through.
A 5.1 magnitude earthquake shook Los Angeles, triggering a rock slide.
This is actually the second noticeable earthquake that this area has had in just the past 2 weeks. And since the earthquake hit, there have been more than 100 aftershocks, including one that was 3.4 just a short time ago.
The ground shook just after 9 Friday night.
We might be experiencing, I should say, an earthquake here.
And seismologists are particularly worried about this quake because they think this fault may be reawakening. We haven't heard from this particular fault, they don't think, in several decades. The reason they really don't want to see this fault wake up again, it runs right through downtown LA.
Yeah, the second largest city in the country, Ryan.
This footage shows a rare tornado that ripped through Northern California, damaging dozens of homes, while debris smashed windows and ripped holes in walls, and left residents of the city of Roseville in shock over the unusual event.
0.8 magnitude quake hit the northern part of Yellowstone National Park in Wyoming. It shook the ground at about 5:30 this morning, California time. It was felt in towns along the Montana-Wyoming border, including West Yellowstone.
This morning,
tsunami sirens blaring. Chaos as an 8.2 magnitude earthquake rocks the coast of Chile, driving almost 1 million people to evacuate their homes. Fires burning after a 6-foot tsunami followed the quake.
The shockwaves were felt hundreds of miles away, shaking buildings as far away as Bolivia and Peru.
People are dead and many more injured.
For the past 7 days, more than 1,700 earthquakes worldwide. We do still have tsunami advisories.
The earthquake even triggered microscopic seismic measurements in New York's Central Park. There have already been more than 24 aftershocks. In just the past 2 weeks, hundreds of earthquakes have been shaking Chile's far northern coast.
Just about 24 hours ago, there has been another strong earthquake off northern Chile, and the emergency office there has ordered preventive evacuation of the coastline in the north of the country. There's a quake magnitude 7.4 offshore.
Latest official report on climate change that says it is underway and we are already suffering the effects. Here in Australia, air and ocean temperatures are increasing, with waters off our east coast amongst the fastest warming in the world, and deadly algal blooms, and rainfall is expected to decline across southern New South Wales and Victoria. We should have 5 seasons in Australia, adding a second spring, basically shortening autumn and winter by 2 months.
The dangers of climate change are set to get much worse.
Australia can expect more intense rain and drought, greater bushfire danger and worse cyclones.
Warming across every state, every territory and every season in Australia.
It's the superstorms bringing nations to their knees. The searing sun turning the earth into a tinderbox, leaving the ground cracked by drought, and the crashing waves of rising seas. But it seems this extreme weather isn't random. A UN report says this is climate change, and things are only going to get worse.
We have reasons to believe that if the extent of climate change continues to increase, then the very social stability of human systems could be at stake.
Today's report is somber reading. Rising temperatures and changing weather could mean more crops fail, so food is scarce. Wildlife will face extinction. Rising sea levels could make water undrinkable, with flooding forcing millions from their homes. And the threat of war will rise as people fight for resources.
US President Barack Obama has warned Russia that any military intervention in Ukraine would lead to unspecified costs. There are reports of Russian troop movements from and into Ukraine's Crimea region.
We are now deeply concerned by reports of military movements taken by the Russian Federation inside of Ukraine.
One of the world's most deadly infectious diseases is spreading across parts of West Africa.
The country is facing an unprecedented epidemic of Ebola.
An epidemic of an extent that's never been seen.
The President of Guinea has urged the people not to panic.
Its movement across Guinea makes it more serious than any previous epidemics.
The strain can kill up to 90%.
The amount of warning time you can expect is 6 or 7 seconds.
As big as a 15 megaton city killer nuclear bomb.
If we ever announce that there is one that's going to hit, and we don't have an answer to what are you going to do about it, you're going to have public panic.
It's only a matter of time before the next big one hits us.
Technology is available today so that when the Earth is in fact threatened by an asteroid, we can move it out of the way so that it doesn't hit the Earth.
Checking out traffic this morning along the Kewy Gardner, Guy Valentine.
It's a bit of a battle for drivers without cover. I'm talking if you don't have any shade, you're fighting some pretty bright sunshine.
Also caution on Highway 7 going east and northbound Don Valley Parkway on the ramp to eastbound 401. We've got a disabled vehicle.
June the 14th, 2002. It was just another busy workday with all the usual hustle and congestion. With all the close calls and near misses that people all over the world have come to accept as the normal level of risk in everyday life. But on that day, high overhead and behind the sun, what no one saw coming What no telescope on Earth was able to see against the blinding light was an asteroid big enough to destroy an entire city. From behind the Sun, asteroid 2002 MN came hurtling towards Earth, faster than a speeding bullet. It shot past, less than a third the distance to the Moon, and nobody saw it, until 3 days later, when the rock emerged from Earth's shadow into the night sky, going away.
It looks like the Earth just dodged a bullet. Actually, it was an asteroid. Scientists say it blew by last week at a distance they describe as a close shave.
The airline industry would call this a near miss. Scientists who study asteroids and comets called it a problem.
The threat of asteroid impacts on the Earth is very real. We know that throughout history this has happened. The craters we see on the Moon are examples of the kind of impact history that the Earth has had. But it also happens very rarely. So it's a very unusual kind of hazard. It's a hazard in which the risk in any one year is very low, but it does happen, and if it really did come about on our watch, it could end civilization.
These cosmic bullets originate on the far side of Mars, in the main asteroid belt, where a bracelet of celestial debris circles the Sun. Millions of rocky fragments, building blocks of a planet that never quite came together when the solar system was formed. What's often depicted as a busy cosmic junkyard is actually more like a big empty speedway. The rocks are far apart and moving very fast, ranging in size from pebbles to boulders to rocks the size of Mount Everest. Occasionally, the tug of Jupiter's enormous gravity drags an asteroid off course, causing it to crash into another asteroid. Some veer away into new orbits that cross the paths of Mars, Earth, Venus or Mercury. Another ring of debris called the Oort cloud is the source of most comets, which are big, rocky ice balls that orbit the Sun and cross the paths of the inner planets. All the inner planets and our Moon bear the scars of numerous asteroid and comet impacts.
We do get hit all the time by pieces of debris from asteroids and comets. In fact, 40,000 tons of cosmic debris plummets into the atmosphere every year. We see them every night as shooting stars. They don't hit the Earth very often, but when they do, clearly it isn't just going to be a matter of a shooting star seen in the sky. So it is inevitable. It's only a matter of time before the next big one hits us.
Even small rocks can make a big impression. In 1908, about 2,000 square kilometers of Siberian forest were instantly flattened as an asteroid exploded near the Tunguska River. The impact site was so remote, researchers had to mount a wilderness expedition just to find the place. When they arrived, there was no crater. Paintings, based on eyewitness accounts, described a fireball. A horrendous explosion in the sky.
Didn't actually come crashing down to the ground. It exploded maybe 5 to 10 kilometers up in the atmosphere, and that made a big blast wave in the atmosphere, and that is what did the damage.
All this was caused by a relatively small asteroid, somewhere between 50 and 100 meters across. Roughly the same size as asteroid 2002 MN, the one we couldn't see coming. Tunguska's 2,000 square kilometer blast wave would have leveled London. But as bleak as the thought of cosmic collision may be, there is at least a glimmer of hope.
One of the special things about the asteroid impact problem is that unlike the weather or earthquakes or other natural hazards, we, at least in principle, we could do something about it.
And when we know one's coming for us, our claim is that the technology is available today to stop it.
On the Earth, we've got active geology, we've got volcanoes, we've got earthquakes, we've got continental drift, we've got rain, we've got wind, we've got storms, we've got snow. All of those things erode away craters, and that, in some ways, actually fools us into thinking that indeed the Earth doesn't get hit as often as it actually does.
Counting craters on the Moon and then estimating how often the Earth gets hit can be a pretty sobering exercise. One scientist who made that kind of calculation was astronomer Ernst Opic, who published his impact estimate back in 1951. The general public, however, paid little attention to the science or the implications. But one individual who did take the issue to heart was Lembit Opic, the astronomer's grandson, who got himself elected to Parliament.
My grandfather is the reason why I carried on in politics, what he initiated in science. In essence, he was a pioneer. He saw the danger of asteroid and cometary impacts with the Earth, and he had the courage to speak up about them. And he did that at a time when it wasn't really taken seriously, in the 1950s and 1960s.
After years of pushing and prodding, Lembit Opic convinced the British government to commission a comprehensive scientific study of the asteroid and comet threat. The expert conclusion was, the threat is indeed real.
The government has set up a task force to examine the risk of an asteroid hitting the Earth.
Still, skeptical politicians might want to get on the bus and take a trip to the Natural History Museum. Ask any schoolchild who's been there recently, and you'll hear a fascinating and truly scary tale about what happened to the dinosaurs.
The dinosaurs were alive here. They were dead when this sediment was deposited, and this layer is one of the most unique layers in Earth history.
In 1980, the discovery of iridium beside a layer of clay which marked the end of the age of dinosaurs led Lewis and Walter Alvarez to publish a theory that a huge asteroid or comet had hit the Earth 65 million years ago and wiped out the dinosaurs. But for this concept to be confirmed, there had to be a crater. There may be tons of dinosaur bones in these dry canyons, but where on earth was the big crater? Just the kind of mystery a budding young scientist would love to solve.
When I went back to...
Off the coast of Mexico's Yucatan Peninsula, Dr. Alan Hildebrand investigated a huge gravity anomaly discovered by oil drillers back in the 1950s. Put that together with a semicircular magnetic anomaly and you get a massive crater, 180 kilometers across, near a little village called Chicxulub Pueblo. Most of the crater is underwater now. Erosion and continental drift have covered the visible evidence. But 65 million years ago, this was ground zero.
This object would have fallen through the atmosphere in just a few seconds. Just going through the sky, it would have been brighter than the sun. As soon as it contacts the surface of the shallow sea in Chicxulub, of course, it starts propagating the shock wave down into the planet, and it keeps pushing into the planet, and it only gets stopped maybe about 30 kilometers down. The pressure wave would have traveled around the entire planet in the atmosphere. You could have heard the impact on the other side of the planet. The giant impact fireball rising out of the hole, it would have risen, say, 10,000 kilometers above the surface of the planet. Near the impact site, it would have been so hot, it would have evaporated the clouds and been hot enough to make the forest, even a green forest, begin to burn.
For Alan Hildebrand, finding that crater pretty much clinched the argument. Planet Earth had been all but sterilized by a rock the size of Mount Everest.
3/4 of the species of large animal life went extinct.
We have made the case. We've got the qualitative information and we've got the statistics to show that there is a very serious risk.
If you wanted to save planet Earth from cosmic disaster, where would you find people with all the right stuff to do the job? Well, Houston, Texas might be a good place to start looking. This town has that rarest of breeds, the space cowboy. Houston is home to NASA's Johnson Space Center, where rocket science is a way of life and astronauts learn their trade.
If you could roll me 90, then go down. I'll come in on my side.
Behind a swimming pool big enough to swallow.
I'm going to go from here to here.
Dr. Franklin Chang Diaz is one of the lead researchers, as well as an astronaut with 7 shuttle missions under his belt.
And in fact, there was a time in one of my flights where we got hit by very tiny micro meteorites, perhaps, or some sort of orbital debris, which made little tiny dents or little craters in the windows of the shuttle.
Well, that tube is welded. Yeah, I did it. You already welded it. Yeah, I did it.
First-hand experience with rocks in space gave birth to a new idea and a dual purpose to Chang Diaz's work here. His rocket engine has been developed for long-distance missions to Mars, or as far away as the icy moons of Jupiter. But it could also be used to push a dangerous asteroid out of harm's way.
I am concerned enough to think that we need to not waste time arguing about it as to whether it's real or not. I think we need to move ahead and do the demonstration, because even if this is a threat which has a very low probability, all it takes is one, and we are history.
But before we can send a spacecraft chasing after a rogue asteroid, we have to know where to look for it. In the American West, if you drive across the desert to the White Sands Missile Range in southern New Mexico, you'll find the most powerful and effective asteroid hunter on Earth. Scientists here have tested everything from rockets to the very first atomic bomb. Today, across the valley floor from the Trinity bomb site, the US Air Force has installed one of the world's most advanced telescopes. This state-of-the-art technology was developed by MIT's Lincoln Laboratory as part of the Star Wars anti-missile defense system. These may not be the world's biggest telescopes, but they clearly are the best when it comes to finding deadly rocks in space. This is LINEAR, the Lincoln Near-Earth Asteroid Research Facility.
On a given night when we scan the sky with this, we'll find perhaps 10 to 12,000 moving objects in the sky. Now, most of those are main belt asteroids and as such don't represent any danger to Earth. But on the other hand, something like half of those will be brand new discoveries, and buried in there will be 1 or 2 near-Earth objects.
Because the Earth rotates, the sky is always moving overhead. To get a clear picture of an asteroid, you have to make the sky stop moving. And you do that with a telescope that can track or follow the stars. This way, you can take time-lapse pictures that isolate the blur of fast-moving asteroids against a crystal-clear sky. It then records these pictures like a TV camera on a computer chip that has 20 times more detail than the picture you're now watching. The linear computer deletes previously known stars and planets, leaving a less cluttered time-lapse sequence of the new discoveries. At the end of each night shift, Linear's thousands of new discoveries are emailed to the International Astronomical Union's Minor Planet Center at Harvard University. A team of only 3 scientists must cope with the avalanche of new sightings, searching for potentially hazardous asteroids or comets. Computers make a rough calculation of an asteroid's orbit, but it's up to Brian Marsden to estimate the level of risk.
They may be reporting 50 or 60,000 observations from one night, and it takes a while to get through that. But so we look first at the fast movers and see if there's anything interesting there. H is equal to sine delta. We do sometimes get close to 70 or 80,000 observations a day, almost one per second. There are some days when we effectively have one observation per second.
Even with fast computers, Marsden's team can make only a preliminary calculation of each asteroid's orbit. 5 shots in one night cover only a tiny segment of an asteroid's orbital path.
You can't solve for the orbit completely from that, but the fact that you're seeing motion over a half an hour or an hour, something like that, does allow us to get a partial solution for the orbit.
Refining the orbit gets complicated. When 2002 MN shot past, its trajectory was warped by Earth gravity, and scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, had to add that to their calculations.
Here's an animation I put together of the asteroid last year, which was discovered after it passed by the Earth.
An elite team of mathematicians and celestial mechanics is now working full-time on a computerized warning system.
Our orbit animation, you can see how when it returns out to the asteroid belt, the close approach to the Earth has changed its orbit, and it's no longer returning to the same place it started.
Because 2002 MN will circle around the Sun and come past us again, the NASA Orbital Mechanics team will have to adjust the calculation in order to know whether it will ever pose a danger to Earth at some point in the future.
So here we've zoomed in on the Earth-Moon system and we're looking down. You can see how close it came to the Earth. It went over the top. And how you can actually even see the bend in the trajectory. So it's a great example of how a close approach to the Earth, or in fact any planet, can be used to, or can significantly change in orbit.
To know where an asteroid is likely to be in the future, you need a model of the solar system. Mechanical models that show the relative motions of the Sun and planets have been around since the early 18th century. They're called orreries. What the celestial mechanics at NASA had to do was create a new digital model. One that includes the gravitational attractions of all the planets and the Sun, and all the other forces that can affect where an asteroid might go.
You just compute what forces are acting on this particular asteroid from all the planets and many of the minor planets in the solar system, and then we can actually trace the motion of that object around the solar system for hundreds of years.
For scientists, the acid test of their mathematics came when a strange new comet raced toward Jupiter. A stream of cosmic bullets that would shock and amaze millions here on Earth. In the spring of 1993, the eyes of the world turned almost in unison towards a doomsday rock like no other. From the far side of the solar system, it flew in a death spiral toward the largest planet. Gene Schumacher, his wife Carolyn, and their colleague David Levy had discovered an odd-looking streak of light that turned out to be a fractured comet. 21 large chunks of icy rock and cosmic dust heading towards Jupiter.
We knew we had something very unusual. It was so unusual we were a little unsure just what we were dealing with.
NASA asked Paul Chodas and his team to calculate the orbit and predict whether this new comet would actually hit Jupiter.
And it started off at some 60%, and before long it was 90%, and this was a year before impacts. As the impacts approached, we continued to predict not just the impact probability, which went very high, but where and when the comet fragments would hit the planet. And it was a prediction months in advance, and as we got closer and closer to the impacts, I kept wondering, well, is the math right? Will this actually happen the way it was predicted?
A giant comet is on a collision course with Jupiter.
Everybody on Earth who was paying any attention wanted to see if the comet would actually hit Jupiter.
And we have liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
NASA's Hubble Space Telescope set its sights on the planet, and the pictures of what happened next were truly stunning.
Right there! Get it! Wait.
And then the impacts occurred. We were within minutes of getting the right answer on the time of impact, and the location of impact turned out to be just right.
Over the next week, 20 more fragments of the comet crashed into Jupiter, some leaving scars as large as the Earth.
Bang on its cosmic schedule, the comet's first impact was recorded by NASA within the last hour.
When fragment G slammed into Jupiter, releasing an amount of energy equivalent to about 6 million megatons of TNT.
In the wake of SL9, a group of concerned scientists gathered in Italy for a brainstorming session. They created a brand new international organization called the Space Guard Foundation.
Okay, I'm going to join.
To promote the discovery and study of near-Earth objects.
Some people imagine that there are lots of astronomers out there scanning the sky looking for incoming comets and asteroids, and that, of course, is not true. In fact, until recently, there was hardly anyone out there looking.
It's going to glow for about a half an hour and set everything on fire around you.
But whose job is it to defend planet Earth? Weapons scientists from the United States and Russia had already held a series of meetings and came up with their own ideas about how to deal with the impact threat.
Blow off some material, you get a reaction in this perpendicular direction.
The military establishment under Star Wars had created a whole lot of devices, or at least concepts, for weapons in space and devices in space. And in the early 90s, when the Star Wars program was looking a little bit iffy, I think there was some motivation for them to try to apply their technology to this newly discovered hazard from asteroids and comets.
The military approach to the problem proved to be controversial. The notion of sending nuclear weapons into space generated an immediate backlash.
Edward Teller was proposing that we blow up an asteroid to show that we could protect the Earth. And I thought that was a pretty crazy idea. Blowing up an asteroid with a big bomb has a lot of problems associated with it, violating treaties, taking a single asteroid and making a swarm of smaller asteroids. It seemed like it was more interest in bombs than it was a serious interest in defending the planet. For NASA, on the other hand, NASA obviously is the natural agency to discover the threat and the objects, but they say no, planetary defense, that's a military obligation and not an obligation of NASA.
Not NASA, not the military. Just when it seemed planetary defense was nobody's job, a tiny speck in the sky would set off doomsday alarms around the world. On a winter's night, the 6th of December 1997, a dim streak of light moving through the constellation Cancer was captured by a telescope in the Arizona desert. Big enough to destroy civilization as we know it, asteroid 1997 XF11 seemed to be heading towards Earth. The initial sighting by the Kitt Peak Observatory in Tucson, Arizona, was relayed to the Minor Planet Center at Harvard University in Cambridge, where a computer made the first rough calculation of the orbit. They were pretty sure it would miss the Earth on this pass, but it would be coming round again, and it looked like there could be a problem in 30 years.
There were indications of close approach to the Earth in 2028. That was about 45,000 kilometers, which really was rather close.
With only a handful of sightings, the orbit calculation remained very rough. It was hard to tell where this rock was going. So Brian Marsden posted a bulletin asking astronomers around the world for more observations before the rock became too faint to see.
I was saying, hey, get your big telescopes onto this. On the one hand, we're only going to be able to observe it for another month or so. We want to improve the orbit calculation and find out exactly how close it is coming.
But one line in the bulletin said that the chance of a collision was small, but it was not entirely out of the question. Within hours of the website PESA had turned up photographs of XF11 taken 8 years earlier.
And as soon as those were placed into the orbit determination process, they confirmed the fact that there was no chance that it could hit the Earth in 30 years.
The public at large was not understanding uncertainty in this. They wanted an immediate answer. Is it going to hit us or not?
But people were paying attention. One side effect of the false alarm was that public and political awareness of the threat had been raised. 2 months after XF11, new hearings were held in Washington and NASA was told to speed up the science of asteroid detection. Finally, it seemed, there was a political will to do something. Congress gave NASA a 10-year deadline to search the skies and get a fix on the largest of the doomsday rocks. They called it the Space Guard Survey. While astronomers geared up to search the skies, Hollywood was going into overdrive.
I would go to every dinner party and I would say, are you aware what would happen if a comet was actually on a collision course with the Earth?
Oscar-winning screenwriter Bruce Joel Rubin was hard at work on the remake of a sci-fi classic. The new film, called Deep Impact, would be a Steven Spielberg production.
High on a mountaintop, an army of scientists work desperately to build this giant rocket, this modern Noah's Ark to carry a few picked survivors of our doomed civilization.
I think the thing that was hardest for me was the realization that people would have to be chosen to survive.
Let's take the ship away from them! Come on!
Probably a very, very small percentage of human beings would be left on the Earth able to survive something of the intensity of the comet that hit and destroyed the dinosaurs. So I felt making this movie is not just a mission to tell a good story, it's to change minds. It's to let people go, this is something real. This can happen to us. This movie is a wake-up call. It's not just a Hollywood movie, it is pointing at you.
As Hollywood released Deep Impact, telling the world in no uncertain terms that cosmic collisions were no longer just a cosmic joke, real-life professional asteroid hunters were making movies of their own. But instead of using cameras, they worked with delayed Doppler radar. Take the same technology behind a police radar system, jump the power to 400,000 watts, and you've got NASA's Deep Space Network, with huge multi-dish systems, like the Goldstone tracking station in California's Mojave Desert.
This is the main room of the pedestal of DSS-14.
The first time radar astronomer Stephen Ostro bounced a signal off a rock in space, a wobbling blot of pixelated data bounced back. What looks like digital gibberish spoke volumes to Steve Ostro.
Radar really does three things at once. One, it works at long wavelengths, so you're sensitive to structure on large scales and metal concentration. The other is you can make pictures. And you can't do this from the ground in any other way. You make pictures of objects, and then we take a sequence of pictures, and we go through a computational process to produce the 3D models. That's the second thing. The third thing is that it makes very precise measurements of distance and speed.
When the 1,000-foot radar dish at Arecibo in Puerto Rico bounced a beam off an asteroid called Castalia, the data was translated into a 3D computer model. The very first radar movie showed how Castalia spins and revealed that it was actually two massive chunks of rock held together by weak gravity. Every time they made the trip to Goldstone for a new radar target, Ostro and his team were like kids reaching into a box of chocolates. They never really knew just what they would find. Asteroid Cleopatra, shaped like a dog bone, was roughly the same size as the state of New Jersey and was made almost entirely of metal. Echoes from asteroid Tutatis produced images of a rocky, cratered surface and a wobbling, tumbling spin.
Every single one of these objects that we've made a shape model of is very different. This is Tutatis.
From a telescopic smudge of light to a 3D shape model, radar gave them physical details and the first clear idea of what asteroids are really like. In the year 2000, the radar movie crew developed a dark and mysterious new image, asteroid 1950 DA, a big rock that gave everybody a bit of a shock.
Once we got the radar data, we began the normal process of just seeing how far in the future we could predict this thing before the uncertainties in the orbit blur out. And in this case, we could go over 880 years into the future. And what was startling about that case was the impact probability turned out to be non-zero.
Non-zero means there is a chance this rock could hit us. On March the 16th, in the year 2880, 1950 DA will cross the Earth's orbit. Will it hit us? The odds? 1 in 300. If 1950 DA does hit the Earth, the most likely point of impact would be at sea. Of all the big asteroids discovered thus far, this is the most dangerous one we know. Eric Asfaug and Stephen Ward have created a computer model of the impact.
Yeah, it's kind of funny how this started. It was with the movie Deep Impact, and I was getting phone calls. Lots of people were getting phone calls about the movie, whether it was accurate, the big cresting tsunami coming across.
The concept here is that this asteroid, which is about 1 kilometer across, will hit the ocean at 17,000 miles per hour, and it'll blow a hole in the ocean about 19 kilometers across and all the way to the bottom. And so when this huge hole of water gets blown into the ocean, the water will run back in again, and it overshoots and then collapses and overshoots many, many times, and each time it pumps out a wave. So it starts out hundreds of meters high, comes ashore on the coast of North America at about 50, 60 meters. Up toward Canada, Grand Banks, it's about 40 meters. 20 meters here in the coast of South America, and about 15, 20 meters all the way over to Europe. These waves would run inland about 4 kilometers. So pretty much everything within 4 kilometers from the beach would be covered up repeatedly. And so we'd pretty much be wiped away like you're scrubbing the floor. You know, just scrub like this, and it's pretty much all be carried back out.
In February 2001, a NASA spacecraft called Near Schumacher made the first ever landing on a chunky, pockmarked rock named after the Greek god of love. Asteroid 433 Eros is 33 kilometers long and 13 kilometers wide, one of the largest near-Earth asteroids. The pictures were spectacular. The data will take years to process. Proving that they could land on an asteroid was a major achievement, but in the end, they still don't know much about what's inside. How dense? How tough? How brittle or crumbly is it? What would happen if they gave it a good shove? The surface appearance of any dark and mysterious object can be very deceiving.
So these two spheres, as far as I can tell, have exactly the same mass, the same compressibility, the same color. If I were a spacecraft orbiting these and these were asteroids, I'd be very hard-pressed to tell which was which. Yet, if I dropped them from a height, and only one of them bounces, really illustrates the fact that one of these responds elastically and one of these responds like a lump of clay. And it's critical to really go and find out what's inside before we even start thinking about moving these things around.
When a 3D model of the asteroid Castellier got smacked in a computer simulation, a problem occurred. An impact with the same energy as the Hiroshima bomb turned Castellier into a pile of rubble, but did not deflect its trajectory in any significant way. But there are other ways to apply force to deflecting an incoming asteroid. Using the power of the sun to push dangerous rocks out of the way may not be so far-fetched after all.
This is a typical near-Earth asteroid. Its name is Galevka. It's about half a kilometer across. It's a hazardous asteroid. Its most likely fate is going to be to strike the Earth someday, thousands of years from now.
Modern-day researchers like Eric Asfaug say the idea of a giant orbital magnifying glass to burn space rocks could work.
You create a vapor plume in one direction, and that starts the asteroid moving in the other. It's a very gradual process. It's not going to happen instantaneously. You need to know where this guy is 100 years or 50 years ahead of time. But if you do, you've got all the time in the world for a satellite to sit there, no human intervention whatsoever, and it'll gradually shove the asteroid into a different orbit, and it'll miss the Earth.
Some of the technology to do this already exists. Take an inflatable parabolic antenna the size of a tennis court, convert it to a solar collector, and use it to focus sunlight on an asteroid. The Russians have built and are testing a giant sail that captures the minute pressure of sunlight. Just attach the sail to an asteroid and let the rock hitch a ride to someplace else. But using the sun to save the Earth means waiting for nature to do the work. If we don't see an asteroid until the last minute, solar power would be too little, too late. A nuclear electric plasma engine could push an asteroid out of harm's way. The rocket technology at this NASA lab in Houston, Texas, could provide the power for a space tugboat. A group of astronauts and aerospace engineers is designing the B612 mission to prove that asteroid deflection can be done with existing technology.
These are rockets that have very tiny amounts of thrust, but they are so frugal in the use of propellant that we can keep the rocket going for periods of the order of a year.
Building a better rocket engine is only the first step. Figuring out how to latch on to an asteroid, point it in the right direction, and push without losing control is the really tricky part. After years of research, NASA finally had it, the first complete draft of a plan, a demonstration mission, to save the planet.
The asteroid off the impact with the Earth 10 years later so that it misses the Earth, and not just miss it randomly, but miss it very precisely so that we don't simply pass on the problem to our grandchildren.
Midway through 2003, the Space Guard survey had reached the halfway point. A little more than half of the kilometer-sized near-Earth asteroids had been located, and the news was mostly good.
For the 60% that we have already found, I can tell you that there is not a single one that poses a danger. For the 40% that we have not yet found, I can tell you nothing. One could hit tomorrow. Not very likely, but until we've found them and cataloged them, we won't know.
But finding the really big asteroids, those 1 kilometer monster rocks capable of ending human civilization, is only the first part of the challenge. There are an estimated 50,000 smaller asteroids that are big enough to cause tidal waves or destroy vast regions of the Earth.
A 200-meter asteroid happens maybe once every 10,000 years, but that's like 600 megatons to 800 megatons exploding in one place.
Recall the small 60-meter rock that exploded over Siberia in 1908? Well, even though it could have destroyed a city like London or New York, rocks that small are not included in the current Space Guard survey, meaning no one is officially looking for them.
Which, of course, is the same thing as saying that chances are enormous that a Tunguska-sized object will find us before we even see it coming, as happened in 1908. That is likely to happen nowadays, that we won't see it coming.
There has been talk of expanding the search to include smaller asteroids. It'll take more and bigger telescopes and, of course, more money. But until we do, we'll have no idea where those city-killer rocks are.
Evolution on Earth has proceeded in part because every so often a global catastrophe comes along, pushes the reset button, and new things happen.
It wiped out the dinosaurs 65 million years ago, and at the time, we mammals were just furry little creatures burrowing around in the ground, and an asteroid or a comet impact took out our principal competition.
I guess we are saying implicitly, if not explicitly, that we want to do away with that natural cycle.
We've had enough evolution. We like ourselves on the top of the ladder. And we can do something which will change cosmic evolution from this point forward in terms of life on Earth.
Dinosaurs ruled the Earth until a big rock wiped them out. The question is, will another rock do the same to humanity?
Let's get a couple good pictures here.
Humans are the first species with the potential to block a doomsday rock and switch off the evolutionary reset button.
People very often say, look, you're just a doomsayer, you think that these awful things are going to happen. I'm not that way at all. I'm entirely optimistic. The way in which I view asteroids and comets and the possibility of them hitting the Earth is that it's a great challenge. Thank goodness we've realized the hazard and the danger before the next one happens. It's given us time, we hope, to do something about it.
Scientists can study the sky and find the dangerous rocks ahead of time. Astronomers can do the math and predict the orbits. People have the desire and the right stuff to do the job. There's a whole new field of science that could give humanity an option the dinosaurs never had.